don't think there's anything left.
Oh, we're good. Okay. Yeah, take your planner though.
Murray, you should get some more.
Where's the data? You got the data?
Sorry.
Thank you. All right.
Oh, yeah,
6.43. Okay, good enough. I got it.
Forgot seconds. So just use this before.
All right. Okay, so boys and girls, you're going to turn this in, so get out a different sheet of paper from your notes, if you had notes, okay? Trial 1, trial 2. Okay, the mass of the cannon is 7.5 plus or minus 0.5 kilograms. Okay, the mass of the tennis ball, I'm going to guess this mass is about, I'm just guessing, is about, I would guess approximately, the mass of this thing is approximately, I would guess that it's approximately, I'd just say about 62 grams is what I would say. 62 grams. And I'm going to say it's plus or minus 2 grams just because it is so full of methanol. Who knows what its real mass was.
Can you light it on fire?
Okay. So the mass of the ball is 0.062 plus or minus 0.002 kilograms. Right? We need that. I would say these distances are probably what, plus or minus 0.05 meters, right? And then these times can be represented as an average, plus or minus, say, can't they?
Yep.
Okay, they can be represented as an average, plus or minus something, right? Okay, so let's do. I'm going to do the trial 1, and then you guys can figure out trial 2. Okay, so trial 1, this is 5.6 plus 5.89. The average is, I'll say 5.75. Okay, and then I'm going to say plus or minus, and to do that you go high minus low divided by 2, right? So 5.89 minus 5.6 divided by 2. That's about, I'm going to say 0.15. Okay, so this is my time. Okay, so the velocity of the cannon is twice the distance it went divided by the time, right? Kicking my mandolin around here. Okay, see. So twice 1.71 divided by 5.75 equals 0.598 meters per second. I know all those figures are not significant, but I'm not at the end yet, right? And then the momentum relationship, right, is that the velocity of the ball is the mass of the cannon, velocity of the cannon over the mass of the ball, right? So the velocity of the ball is the mass of the cannon, velocity of the cannon over the mass of the ball, right? So 7.5 times 0.59478 divided by 0.062. Okay, so times 7.5 divided by 0.062. That's not bad. That's 71.95 meters per second, right? That's pretty good, isn't it? That's pretty good, isn't it? For a tennis ball. I'm going to figure that out in miles per hour just for fun. That's 161 miles per hour. Actually, a fast tennis serve, by the way, is 140. So I'm actually more impressed by the tennis player than this is using explosives, right? Okay, so that's sort of cheating, right? Now, wouldn't a good scientist want to know what the uncertainty of this is?
No.
Yeah, they would. Okay, so the uncertainty of the velocity of the ball is to the velocity of the ball, which is 71.95. How do we do that? Don't we just go add up all the fractional uncertainties of everything we measured?
Yes.
Because there's no squareds, there's no sign of anything, right? This is all really pretty straightforward, right? So the first thing that was uncertain was the distance. It was 0.05 over 1.71. And then the cannon had a lot of uncertainty, 0.5 over 7.5, right? Plus 0.002 divided by 0.062. And then what else was uncertain? The time wasn't it? 0.15 divided by, can you just do this? I'm pretty sure you can, right? Because didn't we just multiply or divide by all these numbers? Right, and do you remember this is how we do this with uncertainties, right? So you just evaluate this entire thing, multiply it by 71 point that, right? Okay, so times parenthesis 0.05, whoops, plus 0.5 plus 0.002. This should look familiar. Does this look familiar?
Sort of.
Yeah, it does actually.
This is that thing we do when we want the uncertainty. So this is 11. Ends up being 11. Right? Now, I like this. This is the way I would write it if I had to write it. I'd write 72 plus or minus 11. Okay? IB, I believe, wants us to write one-digit uncertainties, which I think is stupid. Okay? Hopefully they won't download that video and look at that, right? Okay, so I think they need to say 70 plus or minus 10. Wouldn't that be one sig fig? And then that digit agrees with that digit or something like that? I don't know. I like my way better. I think people do actually give two-digit uncertainties. Okay. Now, that's trial 1. Trial 2 was, I think, a bit hotter, wasn't it, literally? Like flames came out, right? That was kind of fun. Okay. So for trial 2, you want to calculate that, of course, right? And of course, you're going to end up with a different something plus or minus something, right? Aren't you? So this number is going to be different. This number is going to be different. This number will be different then, right? Which means that number will be different. This will be the same. That'll be the same. This guy will be different, though. Right?
No,
I'm just saying you got to do the calculation again. I'm showing you all the things you got to change, right? Okay. This guy will be different. That'll be the same. That'll be the same. This will be different, and that'll be different. And this will be different. And this will be different. Those are all the things that will be different. Okay. So while you're doing that, I would like to, I've got some other demonstrations that I didn't get to. Let me put away the explosive liquid though first.
Why?
Oh, I don't know why. Just a feeling I've got. Like I don't want to die.
Murray, what's your favorite experiment they've ever done?
My favorite one, I don't know. The rocket's got to be right up there with pure happiness. Okay. Did we talk about explosions? I don't think we did. I think we skipped right on through that. Didn't we?
Yeah.
There we go. All right.
Is that why there's a blessed mark on top of that chair?
Might be. All right. If only there was a way to make a firecracker stand straight up on this chair. Oh, there is. Okay. It's Coca-Cola versus Pepsi. Yeah. All right. How much momentum does this have right now?
None.
What?
None.
What?
None!
Okay. That's Colin Leland back in the day. Did he come into this class?
I don't remember.
Different class. Okay, here we go. You do want to plug your ears